Mathematics, Analysis and Approaches, Paper 1, Time Zone 1, HL, May 2025. This is question number 7 of 5 marks. He is given as a complex number, which is z, 3 to the power of I minus 1. He wants us to write 3 in the form of e to the power of a, and then also find the real value of z and the real value of 1 over z. We want this to be written in the form of p cos ln q. All right. So for that, let's understand what happens when I have y as equal to e to the power of ln x. All right. If I take a ln on both the sides, then I'll have ln y as equal to ln of e to the power of ln x. And now I can apply the law of logarithm, which is log of a to the power of m as equal to m log a. And therefore, ln y is simply going to be equal to ln x into ln e. So ultimately, I will have ln y as equal to ln x, because log e to base e is going to be a 1. And here ln can be cancelled from both the sides. So I get y is equal to x. So if I have y is equal to e to the power of ln of some function f of x, then the function y will simply be f of x. Yeah. So that's the idea that I'm going to be using over here. So I can write 3 as equal to e to the power of ln 3. And that should be good enough. Okay. We know that z is equal to 3 to the power of I minus 1. And I just discovered that 3 can be written as e to the power of ln 3. And this is raised to the power of I minus 1, which can be written as e to the power of I minus 1 multiplied with ln 3. This is nothing but e to the power of I into e to the power of minus 1, and the entire thing is raised to the power of ln 3. And this is for the e to the power of I ln 3 into e to the power of negative ln 3. So e to the power of negative will come down to the denominator. So what I'll have is e to the power of I ln 3 divided by e to the power of ln 3. And e to the power of ln 3 is nothing but 3. So this can be written as e to the power of I ln 3 divided by 3. Okay, what next? So that's the exponential form of the complex number. I'm going to write that in the polar form. E to the power of I theta in the polar form is cos theta plus I sin theta. And therefore, I can write this as cos of ln 3 plus I sine of ln 3, which is divided by 3. So the real part of the complex number z is simply going to be equal to cos of ln 3 divided by 3. Now I know that z is equal to e to the power of I ln 3 divided by 3, and therefore 1 over z is going to be equal to 3 divided by e to the power of I ln 3, or I can write this as 3 into e to the power of negative I ln 3. Again, this can further be written as 3 multiplied with e to the power of I negative ln 3. Now, again, expanding this to the polar form, what I'm going to have is 3 multiplied with cos of negative ln 3 plus I sine negative ln 3. So the real part of 1 over z is going to be equal to 3 cos minus ln 3 can be further simplified like that, and therefore this is going to be ln of 1 over 3, and I can write this as cos of ln 1 over 3. And that's the answer for this question. That's it for this video. Thank you.